Welcome to the deep dive. This is where we take the sources you, our listeners, are curious about and, well, we dig in.
That's right. We try to pull out the most interesting stuff, especially for listeners like the learner who want that knowledge efficiently without, getting overwhelmed.
Exactly. And today you've pointed us towards something pretty cutting edge, a research paper.
Yep. It's titled PaperBench, Evaluating AI's Ability to Replicate AI Research. It's a preprint coming out of OpenAI.
OpenAI. Okay. So our mission for this deep dive is clear. What is PaperBench? Why does it matter? And maybe most importantly, what does it tell us about AI trying to do?
Well, AI research.
It's a fascinating question. Can AI replicate the work of top human researchers?
Right. So the basic idea, PaperBench. It's essentially a new test, a benchmark, designed specifically to see if AI agents can take cutting-edge AI research papers and just reproduce the findings.
All on their own.
Pretty much, yeah. Reproduce them from scratch. It's like asking, can the AI do the science, not just talk about it?
Okay, do the science. I like that. And they didn't pick easy papers, I gather.
No, definitely not. They used 20 papers from ICML 2024. That's the International Conference on Machine Learning, a really top-tier conference.
So high-impact stuff.
Exactly. These were spotlight and oral presentations, kind of the cream of the crop.
And the task for the AI, it wasn't just reading the paper, right?
Oh, much more involved.
Yeah.
The AI gets the paper, yes, but then it have to understand the methods described.
Okay.
Develop its own code base to implement those methods.
Its own code, not the original author's code.
No, that's key. Completely independent code development.
Yeah.
And then it has to run the experiments using that code and see if it gets the same results the paper reported.
Wow. Okay, that sounds hard, like really hard.
It is. The paper mentions this is the kind of task that can take human experts, PhDs, days to complete successfully.
Days for a human expert. And the papers covered a range of topics.
Yeah, quite a range. They span 12 different ICML topics, things like deep reinforcement learning, robustness, probabilistic methods.
So complex stuff across the board.
Definitely. It wasn't just testing one narrow skill. It's a broad assessment of AI research capability. And maybe hinting ahead a bit, the low scores suggest being good in one area doesn't mean you're good everywhere.
Interesting. Okay, so the AI tries to replicate these tough papers. How on earth do you evaluate that? Grading someone's research replication attempt sounds messy.
Yeah, it could be. But this is where PaperBench gets really clever, I think. Their evaluation method is quite innovative.
How so?
For every single one of those 20 papers, the PaperBench team worked with the original authors.
The actual researchers who wrote the paper.
Exactly. Together, they created a custom rubric for each paper.
A rubric, like a grading sheet.
Sort of, but way more detailed. Think of it as a hierarchical breakdown. It listed out all the crucial steps, the expected results, everything needed for a successful replication of that specific paper.
Okay, tailored to each paper. That makes sense for accuracy.
And when I say detailed, these rubrics collectively broke the tasks down into, get this, 8,316 smaller gradable subtasks.
8,000.
Seriously.
Yeah, 8,316. Each with clear pass-fail criteria. So they could measure progress very, very granularly, even partial success.
That's an incredible level of detail. They really tried to nail down what replication means for each study.
They did. And here's another crucial part. The AI agents doing the replication attempt, they never saw the rubric.
Oh, okay. So they couldn't just teach to the test.
Exactly. Like a real researcher, they had to figure out what was important and what needed replicating just by reading and understanding the paper itself.
That tests comprehension, not just following instructions. Smart.
And as you pointed out, no access to the original code bases either. It's all about the AI's ability to understand, code, and execute based on the paper.
Okay, so the AI reads the paper, writes its code, tries to run it. What's the next step in judging it?
Right, so the agent submits its code, usually as a repository with everything needed, including a script often called reproduce. Reproduce, okay.
Then comes the reproduction phase. They take this submitted code and run it in a completely clean, standardized environment. Ubuntu 24.04 with an A10 GPU specifically.
A clean slate.
Precisely. They run that reproduce.sh script and check if the code actually produces the claimed results in this new environment. It prevents the AI from just, hard coding the answers and relying on some quirk of its development setup.
Gotcha. It has to work independently. Prove it.
Exactly. Now, grading over 8,000 criteria across 20 papers and multiple AI agents, that's a lot of grading.
Yeah, how'd they manage that?
They developed another AI, an LLM-based judge called Simple Judge.
An AI judging an AI's research attempt. That's meta.
It has got a meta, yeah.
Yeah.
But necessary for scale.
But how reliable is an AI judge for something this complex?
Fair question.
Yeah.
They anticipated that. They created another benchmark called Judge Evil just to test Simple Judge.
Okay.
On Judge Evil, they compared Simple Judge's grading against human expert evaluations. The paper reports it achieved a pretty strong F1 score, 0.83.
0.83 F1. Okay, so reasonably reliable compared to humans and scalable.
Seems so. It allows them to actually process all these detailed evaluations.
Okay, so we have the rubric, the AI judge.
Yeah.
What kinds of things were in those 8,000 plus subtasks? What were they actually checking?
Good question. At the most detailed level, the leaf nodes of the rubric, there were basically three types of checks.
Right.
First, result match. Pretty straightforward. Did the code, when run, produce a specific number or result reported in the paper?
Okay, the bottom line number.
Second, execution. Did a specific step or part of the process actually happen when they ran the reproduce.esh script? Maybe a particular file gets generated or a certain function runs.
So checking if the process happened, even if the final number was slightly off.
Exactly. It allows for partial credit if the mechanism is working. And third, code development. This looked at the submitted code itself. Does it look like it correctly implements a specific requirement or algorithm described in the paper?
Interesting. So you could get credit even if the code didn't run successfully, maybe due to a bug, but the logic seemed right.
Precisely. It acknowledges the effort and understanding shown in the code, not just the final execution success, which can be fragile.
This seems like a much fairer, more nuanced way to evaluate than just the simple pass-fail on the final result. How did they combine all these?
The final score for each replication attempt was a weighted average of all the rubric requirements the agent satisfied.
Weighted.
Yeah, weighted based on importance. The original authors helped decide the weights, reflecting what they saw as the most critical contributions of their paper. A perfect score satisfying everything would be 100%.
Okay, that makes sense. Right, so we've got the setup, the benchmark, the complex evaluation. Now the big question, how did the AIs actually do? What did the experiments show?
This is where it gets really telling, I think. They tested several major frontier models, the big names, Claude 3.5 Sonnet, some OpenAI internal models called O1 and O3 Mini, GPT-4o, Gemini 2.0, Flash, DeepSeek.
State of the art, basically.
Yep. And the best performing one in the main setup was Claude 3.5 Sonnet, using some extra open source tools for structure. Its average score across all 20 papers.
What was it?
Only 21.0%.
21%. That's it.
That's it. The best model could only replicate about a fifth of the key contributions on average when working from scratch.
Wow. Okay, that's lower than I might have expected. It really puts the complexity of research into perspective.
It really does. It shows a pretty significant gap between current AI and what's needed for robust scientific replication.
Did they compare it to humans doing the same test?
They did. They set up a human baseline. They got some ML PhD students.
Actual researchers.
Right, and had them try to replicate a smaller subset, just 3 of the papers.
Yeah.
The humans could spend up to 48 hours on each attempt.
Okay. And their scores?
On that same subset of 3 papers, the human PhD students averaged a score of 41.4%.
Okay, 41.4% for humans versus what did the best AI get on that same subset?
The best AI on that specific subset was OpenAI's O1 model, which got 26.6%.
So humans at 41%, AI at 26%. Humans significantly better, though still not perfect, obviously.
No, replication is hard even for experts. But yeah, a clear advantage for the humans overall.
Was there anything else interesting in that comparison?
Actually, yes. They looked at performance over time. And here's a twist. In the first hour of working on those 3 papers, the O1 AI model actually scored higher than the human baseline.
Really? Faster out of the gate?
Seems like it. The AI could generate code, or maybe set up the basics very quickly.
Yeah.
But its performance tended to plateau after that initial burst.
While the human
score started slower, but kept climbing steadily over the 48 hours.
Huh. So maybe AI is quick at initial coding, but humans are better at the deeper understanding, the strategy, debugging, sticking with it over the long haul.
That's kind of the interpretation, yeah. AI good at the sprint, humans better at the marathon of research problem solving. It suggests AI struggles with sustained strategic effort.
That's a really fascinating dynamic. Did they look at just the coding aspect? You mentioned that earlier.
They did. They created a sort of lightweight version called PaperBench Code Dev. This only looked at the code development part, using those code development rubric nodes we talked about. Didn't require successful execution.
And how did AI do there?
Much better. On Code Dev, the O1 model scored 43.4%.
43.4% on just coding, compared to 26.6% on the full replication task for that model.
Exactly. It really reinforces that idea.
Hmm.
Current models seem significantly better at writing plausible code based on a description than they are at the full, messy process of making it work, running experiments, and validating the results.
The understanding and coding part is stronger than the making it work and proving it part. Makes sense. Did they see other common ways the AIs failed?
Yeah, analyzing the agent logs revealed some patterns. A lot of models seem to finish too early.
Just stop.
Yeah, they'd either claim they were done, successfully replicated, or sometimes they just declare the problem unsolvable and give up.
Not very persistent.
Not always, no. And there wasn't much evidence in the logs of sophisticated strategic planning or long-term problem solving. They seem to struggle with breaking down the big, complex task and working through subproblems methodically. The paper calls this a weakness in long horizon tasks.
Which is kind of what real research is, right? A long horizon task with lots of unexpected turns.
Absolutely. It requires that sustained adaptive approach. Current AI, at least in this context, doesn't quite seem to have that yet.
Okay, this is painting a really clear picture. So let's bring it back to our listener, the learner. Why is this PaperBench study important for someone just trying to stay up to date on AI?
Well, first off, it gives a concrete, measurable sense of how close, or maybe more accurately, how far AI currently is from being able to automate AI research itself.
Which would be huge.
Absolutely huge. Think about the potential impact on the speed of science, not just in AI, but everywhere, including things like AI safety research, which is critical. Faster progress there could be vital.
Right. It puts a number on that capability, which is usually just talked about vaguely.
Exactly. And the way PaperBench measures it with those detailed rubrics looking at code, execution, results, gives you, the learner, a much more nuanced picture than just a single score.
Yeah, it's not just can AI do research, yes, no. It's what parts of research can it do well and where does it struggle?
Precisely. It helps you understand the specific capabilities and limitations in a complex task, avoiding that feeling of being overwhelmed by just hearing AI is getting better.
And the comparison with humans, that's pretty insightful too.
Definitely provides those aha moments, like the AI being faster initially, but humans being better long term. That challenges assumptions about how AI thinks or works compared to us.
Yeah, that was definitely counterintuitive for me. The paper also mentioned something about specification gaming. What's that about?
Yes. It briefly touches on that challenge. Specification gaming is the worry that a very smart AI might figure out how to get a high score on the benchmark, meet the letter of the rubric, without actually achieving the spirit of the task.
Finding loopholes.
Kind of, yeah. Or achieving the result in a brittle or unintended way. It's a known problem in evaluating advanced AI, making sure your test actually measures what you want it to measure, especially as the systems get smarter.
So even designing the tests is hard. That's another layer of complexity.
It really is. And one last point for why this matters. They open source PaperBench.
The whole thing. The
Yeah.
code, the rubrics.
Yeah, the paper says the framework, evaluation tools, everything. That's great for transparency and lets other researchers build on it, test different models, maybe improve the benchmark itself. Open science in action.
Fantastic. Okay, so let's try to wrap this up. What are the absolute key takeaways from our deep dive into PaperBench?
I'd say number one, PaperBench is a rigorous new way to measure AI's ability to replicate AI research.
Right.
Number two, the results show that while today's top AI models have some capability here, especially in coding, they're still significantly behind human experts. There's a big gap, particularly in strategic execution and validation over long periods.
Quick to start coding, slow to finish the real research work.
That's a good summary. It highlights that AI is currently better at code generation than the full R&D lifecycle.
Got it.
And third, this whole endeavor points towards the massive potential, both good and maybe challenging, if AI could eventually do autonomous research. Imagine the acceleration of discovery.
But also the need to ensure we understand and can manage that acceleration safely.
Exactly. It's a profound prospect.
So for you, our listener, to chew on after this, based on what we've discussed about PaperBench, what do you think are the biggest hurdles remaining before AI could become a truly autonomous scientific researcher? What needs to change or improve?
And beyond the technical hurdles, what might the wider societal impacts be if, or maybe when, that capability arrives? How to change science, innovation, maybe even our role in discovery.
Lots to think about there. And as you mentioned, PaperBench is open source, so if this deep dive sparked your interest, the paper, the rubrics, the code, it's out there for you to explore even further.
Definitely worth a look for the truly curious.
Well, thank you for joining us on this exploration of PaperBench. We hope it's given you a clearer, more grounded view of where AI stands in this fascinating domain. Until next time, keep exploring.